In the realm of nature's wonders, ants stand out as exemplars of resilience and adaptability. These tiny creatures, often overlooked, possess remarkable abilities that defy their size. One such ability is their astonishing resistance to radiation. Ants can withstand radiation levels up to 1,000 times higher than what is lethal to humans. This extraordinary tolerance stems from their unique cellular repair mechanisms. When exposed to radiation, ants rapidly produce antioxidant enzymes that neutralize harmful free radicals, protecting their DNA from damage. This resistance is not solely confined to a single species of ant. Studies have shown that various ant species, from tiny fire ants to larger carpenter ants, exhibit similar levels of radiation tolerance. This shared trait suggests that it is an evolutionary adaptation that has served ants well throughout their long history. Ants' radiation resistance has important implications for our understanding of biological adaptation. It demonstrates that organisms can evolve mechanisms to cope with even the most extreme environmental challenges. This insight has potential applications in fields such as cancer research, where scientists seek to develop therapies that mimic the resilience of ants. But what makes ants particularly resilient to radiation? One key factor is their small size. Smaller organisms have a higher surface area to volume ratio, allowing them to dissipate heat more efficiently than larger animals. This reduces the buildup of radiation-induced damage within their bodies. Another factor contributing to their resilience is their decentralized nervous system. Ants lack a central brain, instead relying on a network of interconnected ganglia. This distributed system makes them less vulnerable to radiation damage, as the loss of one or several ganglia does not immediately incapacitate them. Moreover, ants possess a highly efficient metabolic system. They can rapidly consume oxygen and nutrients, providing energy for the repair of radiation-induced damage. This metabolic adaptability further enhances their ability to withstand radiation exposure. The resilience of ants serves as a reminder of nature's boundless creativity and ability to adapt to even the most challenging environments. By studying these extraordinary creatures, we can gain valuable insights into the biological mechanisms that underpin resilience and survival.